So up until now, I've actually powered up this bandsaw with my welder. Reason being, in my shop, I don't have a 20 amp outlet, but it's a lazy day today. It's raining and there's not much I can do today. So I'm going to rewire this motor down here to a 220 because it has a capacity to actually have dual voltage. Right now, the windings, I guess, are parallel. So it's rigged for low voltage. I will be working on it today and show you how to bring it up to high voltage to run it off of 220.
Okay, they're at Rockwell. They tell you it's a half horsepower motor. Right there you can tell the voltage is either 115 or 230, and it goes along with the amperage. 7.8, 3.9, so it's almost like half. It actually comes with a nice little diagram right on the motor itself. This would be for the low voltage, and that's where I'm telling you it has the two windings basically, and you power both in parallel. This would be a series, which is the high voltage one, where you have the power coming in, the two windings connected to each other, and then out through the other connection. It looks like the wires should be labeled as far as which one's which. Let's see. Let's hope it still has those labels. If not, I'm gonna have to use a voltmeter to find out which is which. Okay, nice. All right. It looks like they're still labeled, so I guess nobody has really messed with this little motor. All right. I'll still show you how to get it done in case it doesn't have, in case it's not labeled, which is usually the case for me. I really lucked out. Okay, so there should be about 6 wires around here.
Okay, hypothetically, let's just say the cables weren't labeled. I am going to get my tester and set it to see continuity, to see which wire goes to which coil. And basically what it is, layman's terms, is if it touches, it will sound off as being, having some sort of continuity, to mean that let's see if it'll work with brass. It should work. Ah, it's got plastic. That's awesome. All right, so you can tell, see, the plastic actually keeps it from having continuity, and the exposed side, there's continuity. Current can run through it, basically. That's all it is. Okay, so there's a total of 9 wires, because it's 6 that are from the actual motor, and then this is actually the plug, which is your ground, your hot and your neutral. So and as far as these 6, 2 are from one winding, the other 2 are from the other winding, and then the other 2 are from your, basically the starter winding, the one that actually kickstarts the motor. So let's find out which is which by using our continuity tester. Let's see. Let's start with this right here. Oh, all right. So these 2 are on. Let's just check these on just for the hell of it. Nothing. What the fuck?
sure everything is disconnected, because like right now we had a false positive. Basically we're still tied up. Here we go. Alright. So yeah. Alright. These two, which is T2 and T1, are from the same winding. Here we go, T1, T2. So in that case, I would just label them with tape if they weren't already labeled. Let's just use green for right now, I guess. We know it's T1, but I will, for the benefit of the video, we'll label it like that. And T2 right here. So I know that's one winding. Okay. Let's try. Let's see this one. This is T3. This shouldn't, because these are another winding. And right here. And this is T4. So 3 and 4 are another winding on itself. Alright. So 3 and 4 will be marked with white tape. And like I said, you just need this to, know which wire is in the same winding, since I can't open, or I don't want to open the motor to see where the wires are coming from. This will do. I was lucky, like I said, it had numbers like this one right here. It says T3. Alright. So, by elimination, obviously these two, okay, and these 4 are out. So that leaves us with these two right here. Which will be from the same mold. From the same. Oh shoot! What happened now? Did not. Alright, let's go back to the white ones. I've switched my voltmeter. It shows 3. Alright, that's for the white. The green. Let's see what the green shows. 3 also. Okay, so these are probably windings. And a T5, T8 should be probably a lot more if they're not even connected, so I don't. Yeah.
I'm wondering if it's even working. That kind of sucks. My starter winding might be out. Okay, I've already tested everything, already labeled it more or less. 5 and 8 didn't show continuity, but it is either the starting winding, because it says right here on the little placard, counterclockwise rotation facing lead end, interchange leads 5 and 8 for clockwise. So that means basically if my blade starts running the wrong way, like if it starts going up, that means this thing is rotating the wrong way, which means the motor is rotating the wrong way. So I would have to swap out 5 and 8 from their so because I can't wrap my head around it why it's not showing any continuity on those two, but I'm just gonna wire it 5 and 8 the way it says there on the placard, and hope I don't get any fireworks. Worst case scenario, it probably won't spin if it has a burnt out starter winding. The other two were similar in ohms, so those are the windings. This has to be a starter, and the placard just confirmed it, that it is the starter winding, since it actually controls the rotation of the motor. So I will be putting lines or power to T1, which is one of the green ones, and T4 and 5, which is one of the white ones with one of the winding ones, and then group all together a green, a white, and a winding, which would be the T8, I guess. Hopefully that gives it the right rotation. Okay, now we have to deal with this plug. It's 125 volt. It's a more important thing, it's a 20 amp. Now in a high voltage, it doesn't really matter which goes to which. They both provide, they're both going to provide a half of what the 240. If it's a 240, it's going to be 120, each. That's why they're both the same color. It's not a silver and a bronze one. It's they're both the same color. The only one that matters is the ground. That's the only one that has to go to the ground. The other two, doesn't matter if it's black or white, as long as red, whatever, as long as one goes to each. But it is important to me, at least, to have the screw part facing away, because you're going to tighten that so that the wider blade is going to go on the left hand side. So I'm going to put the common there, which will carry 110, 115 volts, 120. It all depends on what your house is wired. Slight tug to make sure they're tight, and into the plug itself. Moment of truth. Let's see if we see sparks fly out. Some bump it. We're gonna start it and stop it to see if it's at the right direction. No! Ha! It's going up. Alright, let's switch that out. Unplug it, because we're gonna work on the power. Alright. And basically, like our little placard tape, we have to switch out the starting, which is number 5 and 8, I believe. Here's the 5. P5 goes out of here. From this other little group. This one. G8 right here. Alright, don't let this. It doesn't have an indicator. No sparks. Alright, let's see. Go down. It's going down. Yeah, alright. Here we go. Once we've got our orientation correct, I like to tape up everything just to make sure, as a safety precaution, it doesn't touch anything else by taping together the cables and nut together. And just reassemble it, put it back together.